Here's some .NET vocabulary that you might run into. It's not strictly necessary to know all these words, but when you do run into them, then you'll have a better clue of what is going on. A common language runtime is a file, usually an executable file or a DLL, which runs your code, and it also provides a lot of services for your code. The .NET runtime is the one that is providing us with the list function, the list class, for example. There is also a common type system, which is basically a white paper defining how data types are declared and used and managed inside this runtime. And there's also a common language specification, which defines the features and rules of a language that you can program in, such as C# or Visual Basic. These two languages are CLS compliant, and as long as you only use the data types that are defined by the common type system, and you use a language from the common language specification, and you run it through the common language runtime, then your program is CLS compliant. And as long as your program is CLS compliant and it's only exposing CLS features, that means that your component can be used by any other language that abides by the same rules. XNA is CLS compliant, which is why you can program it using XNA in either Visual Basic or Visual C#. It doesn't much matter. You can even make a component in Visual Basic and then use it, give it to somebody else who can use it in C# code. When you pack something up that is CLS compliant, Microsoft packs it up in something called intermediate language. This is half compiled. It is somewhere in between binary code and human readable code. This is good because the code is secure. Nobody can read it and see all your intellectual property secrets. Yet when somebody downloads the MSIL file and runs it on their computer, then it will be further compiled or optimized for that local hardware. For example, which kind of CPU that the user is using. A file packed up is called an assembly. As you know, we have several files, such as the image.cs file, but when it's all packed up, those files go into the executable file, and one assembly has one entry point, the main function. Another word for it is a portable executable, which is basically just a file with an assembly manifest. And that manifest will declare a few things. For example, an assembly will act as a security boundary so that two programs cannot screw with one another's memory. Makes Windows much more stable. The assembly manifest will also specify what other DLLs that the assembly needs and what version those DLLs have to be. I'm sure you have noticed that DirectX, for example, keeps growing because the download, I mean, keeps growing because each new version contains all the old versions too, so that your program can pick the version of the code that your program runs against. When XNA 2.0 comes out sometime, maybe next year or 2 years from now, your program has in its assembly manifest that it uses the 1.0 version of the XNA framework. So then it will alert the user to that if that is not installed, and otherwise it will just pick the right methods to call. Another word for an assembly is a deployment unit, which is basically one download or one program. And the good thing about assemblies is that they support side-by-side execution, which is just a fancy way of saying that you can start several games running at the same time and nothing crashes. Visual C# also has some vocabulary. The first one is resources. This is simply data that is independent from the source code but included in the assembly, such as graphics, for example. There are 5 types of resources. There are strings, images, icons, audio, and if you have something else, then it goes into the miscellaneous category called files. If your assembly or your project is using some other project, then you need to identify that with a project reference. The rule of thumb when you should have a project reference is if your code instantiates a class that is defined in another assembly, then you must add a reference. Your program has by default one project reference, and that is to the core.NET framework classes. So you don't need to add that. You can use that .NET right out of the box. Project dependencies, they are a similar concept, but they instead identify which assembly should be compiled first. The project that is using the code of another project is called the consumer project, and the code that is being used is called the generator project. Dependencies are less important than references because Visual C# pretty much takes care of dependencies all by itself. Let's quickly look at some of the IntelliSense vocabulary as well, because IntelliSense is just a group name for several different functions in the IDE. Functions which minimize the time you spend looking for help, and it helps you code faster and more accurately as well. The first IntelliSense function is the completion lists. We have used these a lot. When we start typing a word, we get a list box with suggestions what word we're trying to type, so we just hit tab and then we get the whole word. Also, when we have done that and we hit period, we get a list of members, which is called the list members. Of the members inside the .NET class or one of our own classes. If we hover with the mouse over a data type or a variable, then we get some information about that. And similarly, when we are typing in the parameters, when we are declaring a method, we also get a tooltip that lists all the parameters of the different overloaded methods. We'll go through overloading a little bit later on in detail. If you're trying to use a class or a data type without using the fully qualified name, then you get a little smart tag which you can click on, and then you will get the using statement written for you. Code snippets are also part of the IntelliSense system. We've seen those before, like when we wrote CTOR and hit tab, then we got the entire constructor. The interesting thing about code snippets is that you can make your own snippets. We might go through that later on. IntelliSense also has a system for refactoring, which is a bunch of functions in the refactoring menu for changing code without changing the behavior of the code, so that we can, for example, extract statements into their own method instead of having one big method with everything. There's also a renaming function that is a lot better than search and replace. IntelliSense also has wavy underlines, just like Word. Gives you instant feedback. If it is red, then there's a syntax error, most likely a semicolon or a missing bracket somewhere. If it's green, then it's a compiler warning. You need to keep those in control. You can have a few, but not more than a few. And blue is something that stops your program from compiling completely, so you need to edit that before you can continue. And there are also some helper readability helpers, such as the outlining system. We have been using a lot of regions, but you probably have noticed that namespaces and classes and methods are regions by themselves that you can collapse and expand. And colorization is Microsoft's word for code highlighting, so that different parts of the syntax has different colors.